I'm Rajesh Uppal, Director IDST. We bring sharp insights and foresight on defense, security, and emerging tech. Let's dive in.
What if the fuels that power fighter jets, warships, and missiles weren't refined from oil, but grown by engineered microbes? That's not science fiction anymore. Synthetic biology is transforming how we think about energy, and it's rewriting the playbook for both industry and defense. For over a century, fossil fuels have defined military power. Control over oil meant control over logistics, strategy, and influence. But those same fuels are now a global vulnerability, volatile in price, polluting, and dependent on long supply chains that are often contested or exposed to attack. Synthetic biology changes the equation. Instead of drilling for oil, scientists are programming cells, yeast, algae, and bacteria to manufacture fuels and chemicals at the molecular level. These living factories can convert sunlight, carbon dioxide, and waste biomass into high-energy hydrocarbons. The results? Cleaner, renewable fuels with military-grade performance. So how does it actually work? Inside every living cell, there's a network of biochemical pathways, molecular assembly lines that convert raw materials into energy and essential compounds. Synthetic biologists rewire those pathways using genetic circuits, like software patches for DNA. They can insert new genes, suppress others, or design entirely new metabolic routes. This lets them redirect the cell's chemistry towards producing specific hydrocarbons, long-chain molecules similar to kerosene or diesel. Some engineered microbes even use light and CO2, turning sunlight directly into jet fuel. Others rely on fermentation, feeding on sugar, waste biomass, or carbon captured from the air. It's biology behaving like a refinery, but one that runs on renewable feedstocks and operates at room temperature. Around the world, momentum is building. In 2022, the Royal Air Force flew a drone powered entirely by synthetic kerosene made from food waste. The U.S. Department of Energy invested $100 million in next-generation aviation biofuels. And the European Union set a 2030 mandate requiring all jet fuel sold in its member states to include at least 5% sustainable aviation fuel. The aviation and defense sectors are both moving rapidly toward a shared goal: energy that's renewable, secure, and high performance. For the military, this is more than environmental progress. It's a strategic advantage. The U.S. Department of Defense, DARPA, and research partners worldwide are developing drop-in biofuels that can power aircraft, ships, and vehicles without modifying existing engines. At the Naval Air Warfare Center, scientists have already tested a biosynthetic jet fuel called BR1, developed through DARPA's Living Foundries program. It delivers nearly 20% more energy density than conventional fuel and burns cleaner. Meanwhile, the Army's Combat Capabilities Development Command has engineered E. coli bacteria that convert corn husk waste into missile propellant precursors, cutting costs and eliminating toxic petrochemicals like hydrazine. These are not small breakthroughs. They redefine what's possible. Picture a future military base that produces its own energy on-site, using waste materials or seawater, reducing the need for long and dangerous fuel convoys. Imagine aircraft that fly farther on less fuel with zero carbon footprint. Synthetic biology could make energy production as flexible and distributed as data networks are today. Still, the path isn't without challenges. Scaling up these biological processes is complex. Cells can mutate. Fermentation systems require stability, and global standards for biosynthetic fuels are still being developed. But breakthroughs in metabolic modeling, AI-guided enzyme design, and automated bioreactors are closing those gaps fast. And the implications go beyond fuel. The same biological platforms can create advanced materials, lubricants, and even polymers for stealth coatings, all derived from renewable feedstocks. DARPA's molecular informatics and biodesign initiatives are already exploring how synthetic biology can merge with material science to yield next-generation military hardware, lighter, stronger, and even self-healing. Beyond defense, the ripple effects are massive. Commercial aviation, shipping, and heavy industry all stand to gain from drop-in biofuels that work seamlessly with existing engines. Every step forward in the lab brings us closer to a world where carbon neutrality doesn't mean compromise. It means innovation. The truth is, the next energy revolution won't come from the ground. It will come from life itself. From microbes designed to create power, to ecosystems that sustain technology, synthetic biology is forging a new alliance between nature and engineering. And as nations race to decarbonize while securing their energy independence, this fusion of biology and defense may prove to be the decisive frontier. The age of fossil fuels defined the last century. Synthetic biology could define the next. Thanks for watching. Subscribe, follow, or visit idsth.com for more cutting-edge defense and tech insights. See you in the next one.